Hey there, fifth graders. This is Module 2, Lesson 15. This one's going to be all about word problems and converting them or converting measurements within the word problems. And there are going to be multiple steps, as you can see right here, multi-stepped word problems. So not just one math problem, but there's going to be a couple within the actual word problem. So let's get started with number 3. All right, let's look at number 3. Number 3 says each costume, so I'm going to box in each costume, needs 46 centimeters of red ribbon and 3 times as much yellow ribbon. So looks like they need more yellow ribbon compared to red ribbon. They want to know what is the total length of ribbon needed in 64 costumes. And they want us to show our answer in meters. So we have centimeters and we're converting to meters. And like I said, this is a multi-step problem, so we're going to have lots of math involved here, which I love. So let's start with the first sentence. For every costume, there needs to be 46 centimeters of red ribbon. So I'm going to put an R for red ribbon, and I'm going to make a little tape diagram. And this is going to represent 46 centimeters. And then for yellow, it's going to be 3 times as much as the red ribbon. So if I do yellow and I put 3 boxes, is this 3 times more than the red ribbon? You are correct, it is. So now what I would need to do is figure out how much ribbon of red and yellow I would need to make just one costume, and that would be taking 46, because technically every box right here is 46 centimeters. And whatever I'm doing, you should be copying down as well to show our thinking. So we have 46, and we're going to have to multiply that by 4. So here's our first step. We're going to do 46 times 4. 4 times 6 is 24. Carry your 2, bring down your 4. 4 times 4 is 16 plus 2 more. That would be 18. So for one costume, we're looking at 184 centimeters for just one costume. But we don't want to know how much length ribbon is needed for one costume. We want to figure out how many is for 64 costumes. So now we're going to take 184 centimeters, write this down with me, and we're going to multiply it by 64 costumes to figure out how much total ribbon would be for 64 costumes. So I'm going to go ahead and do 184, and I'm going to multiply that by 64. I'm going to have 2 partial products because 64 has 2 digits in it. So 4 times 4 is 16. 4 times 8 is 32. Plus 1 more is 33. Carry your 3. Bring down your 3. 4 times 1 is 4. Plus 3 more is 7. So I'm done multiplying by the 1s in 64. I'm crossing the numbers up on top. I know I need a 0 placeholder because my answer needs to start in the tens. 6 times 4 is 24, so I'm going to carry my 2, bring down my 4. 6 times 8, that is 48, plus 2 more is 50, so carry your 5, bring down your 0. And 6 times 1 plus 5 more would be, or 6 times 1 is 6, plus 5 more would be 11. And so now I'm going to go ahead and add those up together. This is 6, 7, 7, 1, 1. So it looks like for 64 costumes, you need 11,776 centimeters of ribbon. But we're not done yet because they don't want the answer in centimeters. They want the answer in meters. So let me pull up that conversion chart to help us out. So there's that conversion chart, and I'm looking for, here's the 100 centimeters, which equals meters. So it looks like if we already have centimeters and we want to find meters, it looks like we are going to go from centimeters to meters, and centimeters are smaller and meters are bigger. So we are going to be doing the opposite of what it says down here. 1 meter is 100 centimeters. So what happens when I have 1 centimeter? How many meters is that? Well, it's not going to be 100. It's going to be a fraction, 1/100th of a meter. So that's going to help us in our conversion. So let's convert. Let's stick it up here at the top. So I have 11,776 centimeters, and I'm going to break apart the factors. I have 11,776, and I'm going to multiply that by how many centimeters would give me 11,776 centimeters? That would be 1 centimeter. Now I'm going to go ahead and write 11,776, and I'm going to multiply that. Now I'm going to convert. We're converting 1 centimeter into meters. Well, what fraction was that down here? That was 1/100th. So 1 centimeter as a meter is 1/100th of a meter. Now I'm going to multiply 11,776 times 1 over 100, 1/100th. So think of 1/100th, adding that 11,776 times. Well, the denominator is going to stay the same. And then 11,776 times 1 would be 11,776 as our numerator. And this is it as a fraction, but like I said in the last video, the last lesson, this fraction bar represents division. So we can actually quickly do 11,776 divided by, please write this down, by 100. Now I'm going to pull out my place value chart. There it is. I'm going to put 11,776, and I'm dividing. So I'm going to the right and going 2 times because I'm dividing by 100. So that 6 goes into the hundredths, that 7's in the tenths, and decimal point 711. So it looks like the answer in meters is 117 and 76 meters. And now we need to complete the sentence to the question, what is the total length of ribbon needed for 64 costumes? Let's write our sentence neatly somewhere. So here's our statement. The total length of ribbon needed for 64 costumes is 117 and 76/100 meters. So we're answering the question that we underlined in the word problem. And here is our answer. Hit pause if you're still working and you aren't ready yet. But let's go ahead and look at the fourth problem. All right, let's look at number 4 here. We've got the word problem of when making a batch of orange juice for her basketball team, Jackie used 5 times as much water. So let's circle that, 5 times as much water as the concentrate. Another clue says there were 32 more cups of water than the concentrate. So they want to know how much juice did she make in all. So let's kind of step back a bit and kind of read it again one more time carefully. So I know that Jackie is making orange juice for her basketball team. And Jackie used 5 times as much water than the concentrate. Concentrate's the actual juice, and then you add water to make more of the juice. And then there were actually 32 more cups of water than the concentrate. So let's do a tape diagram. We do know that there's concentrate, so we'll label that as C, and then we'll label that as W as water. So this is concentrate and water. It says that Jackie used 5 times as much water as concentrate. So if concentrate was just one little box, That means for water, if it's 5 times as much, that's going to be 5 little boxes. Okay. And then we're given the clue right here that there were 32 more cups of water than concentrate. So here are the 4 boxes of water that are more than the concentrate. So right now, just 1 box for water and concentrate are the same, but here's 4 more boxes. And we're told that those 4 boxes right there are equivalent to 32 cups. And so we want to figure out how much she made in all. So that's actually figuring out what all these boxes are and then adding those up or multiplying. So let's start with right here. If we know that these 4 boxes is 32, what number, if you add it 4 times, would give you 32? Hopefully you're picking up that, hey, that 8 plus 8, that's 16, plus another 8, that's 24, plus another 8, that's 32. So it looks like each box is going to be an 8. So that means the water over here, the empty box, is going to be an 8. And the concentrate is going to be an 8. So it looks like there's 8 cups of concentrate. And then there is 5 boxes here total, and there's 8 in each box. So there's altogether, there's 40 cups of water. So to figure out how many cups of juice she made, we're going to do, since we have 6 boxes, and we multiply that by 8 cups, and write this down as I'm writing it down, we're going to get 48 cups of juice she made. So adding your sentence to the question, Jackie made 48 cups of orange juice. And now let's look down at question B. All right, so question B says, she poured the juice into quart containers. Quart containers, they want to know how many containers could she fill, or how many quart containers could she fill. So let's go back. We had 48 cups from the previous problem, and we want to figure out how many quarts she can make, how many quart containers. So I went ahead and pulled up the conversion chart again, and I'm going to highlight. So we are trying to go from cups all the way to quarts. So if you look at it, 1 pint equals 2 cups, and 1 quart equals 2 pints. So here's the trick on this. We want to go from 1 quart down to the cups, if that makes any sense. So we kind of want to figure out, okay, well, 1 quart is actually how many cups? Because we know that 1 quart is 2 pints, and 1 pint equals 2 cups. So technically we're going to be adding the 2 2's together, and 1 quart is equivalent to 4 cups. But if you look back in our word problem, we're going from cups to quarts. So we're going from small to big. So let's flip it. And let's say, okay, well, 1 cup is actually going to be not 4 pints, but it's going to be 4 quarts. It's going to be 1/4 of a quart. So that's our conversion. So let's go ahead and solve. We got 48 cups, and we're going to separate the factors. We got 48, and then we're going to say, okay, 48 times how many cups would give us 48 cups, and that's going to be 1 cup. And then 48 times, here we're going to convert the cup to the measurement that they want, which is quarts. And since a cup is smaller than a quart, this measurement right here, it needs to be a fraction. So 1 cup is 1/4 of a quart. And then 48 times 1/4, just like all the other whole numbers times a fraction, we're going to keep the denominator the same, which is a 4. And then we're going to say 48 times 1 is going to be 48 as our numerator. And that's going to be quart. So 48 over 4. Remember that fraction bar represents divide. So technically we're doing 48 divided by 4. Think of it, 40 divided by 4 is 10. So 8 divided by 4 is 2. And if you add 10 plus 2, 48 divided by 4 would give you 12. So the answer is 12 quarts. And so now we can write our sentence out for this word problem. So your statement would be, Jackie could fill 12 quarts as your sentence. All right, so make sure you have all the information that I wrote on the video to help you understand how to do these kind of not really difficult. They just take time. They take time and some thought to actually how to model this. And hopefully you have something neat and clean on your paper so that when you have to do an assessment or a quiz or an exit ticket, you have some notes or resources to look at. And that ends lesson 15. And heads up, you just are now halfway through the module. And so when you see me next or hear me next, when we do the next lesson, we're going to get into the long division. So congratulations, halfway done module 2, and I will see you on the next lesson.